Let's keep this quick. You want to know how to use assembly. I am one of the options to do that. Let's go. So, to start, we have main.asm right here. If we look at a CPU as bare bones as we can, all we see is instruction, execution. That's all we need. So, how do we do that? Well, CPUs have a thing called registers, where something gets put into those registers and it will remember that. Also, don't worry, just because two programs use the EAX register doesn't mean they'll crash, simply because it has enough memory for all of it, right? So every single thing has its own little place in that CPU, kind of a virtual machine, if you will, for that program. Now let's make an assembly program like this C program right here. Now, because I'm running malware on this software, apparently it's named Windows, I'm going to be showing you the Windows version of this assembly program. I might make a Linux version later. It's a lot simpler, in my opinion. For now, we're just going to use something called gas syntax. I'm not going to get into that, just know it's different. So let's start by making an entry point. Basically like the main function in C. Quite literally exactly like the main function in C. .global underscore main, because it's different, because it's assembly, why not? Now here is something called a label. A label is like a function, but not. Now for the following instruction, we can't just return. We have to put something in the EAX register. Now you don't exactly have to know why it's EAX, just know that EAX, EBX, ECX, and EDX are used with returns. It's kind of like an argument in a function call. The arguments for return 0 are very simple. It's just EAX. So, we will do move L, L stands for long, just like in C, and then in gas syntax, this is in fact the number first, then the register, rather than the register, then the value to put into it. Numbers are prefixed by a $sign. So it's $0, comma, and then, because registers are prefixed by a %sign, it's %sign EAX. Now, the following line, return, done. This is it. If I save this, go to a terminal, and now type gcc main.asm m32, because, you know, 16-bit is just too modern. Tac O for output, main.exe. Cool. Not to worry, I figured out the error. If you rename main.asm to main.s, GCC won't have a panic attack. And not only that, you will also come to find that apparently this is why my syntax highlighting hasn't been working. So, GCC main.s -m32, because 64-bit is just too modern for us, tac O for output, and then main.exe. Now, if we run /main.exe, nothing happens, obviously. But now if we want to find out if it actually returns 0, because I'm in PowerShell, I'll do echo $, last exit code. And it was in fact 0. And if you're watching this thinking, oh, I'm just going to set my exit code to whatever to test, it's good for testing, but remember that exit code 0 is meant for successful exit. If it's anything else, your computer might not think anything weird. However, you as a user might, considering that it is kind of the standard that exit code 0 is the only successful output. If it exits with anything else, people will usually assume that it's an error, so be cautious with what number you choose to return. Hi, editing me here. This is the part of the video where it turned into a 55-minute long search of me trying to figure out how to print Hello World. Fuck Windows, I'm going back to Linux. I'm never Alright, thanks for watching.